What in the world do chemical engineers do?
Make life-saving medicines accessible to everyone.
Develop and deliver new energy sources safely and responsibly.
Eliminate plastic waste from our oceans.
When it comes to getting things done, chemical engineers have a pretty full to-do list. We do the math, science, and engineering to make medicine accessible, water drinkable, air breathable, the deep thinking to make the environment sustainable, systems affordable, safety reliable. We make discoveries scalable, and the inconceivable feasible. So what in the world do chemical engineers do? We take things that have never been done and get them done. For good. AICHE, doing a world of good.
What is chemical engineering? And why would I want to become a chemical engineer?
I think students should choose chemical engineering as a major if you're fascinated by how things are made. How do they work? When I say things, I kind of mean all things.
We think about the COVID vaccine and how it's going to be delivered.
Once there is a vaccine, it'll be chemical engineers that scale up the production of it, to make it affordable for people.
I'm Alan Guyman. I'm the chair of chemical and biochemical engineering here at the University of Iowa. What our purpose is to really help you understand, is chemical engineering the best degree for you? The best degree might be mechanical engineering or civil engineering or biomedical engineering. Lots of great options here at the University of Iowa. We believe that for many of you, chemical engineering will be that best degree. What makes a chemical engineer, and why would someone choose chemical engineering? This sounds like a great thing to be able to do. Well, usually when we ask our students why they became a chemical engineer, it was because they liked chemistry, they liked math, and they wanted to solve problems, and they wanted to make a difference in the world, and that's exactly what they do.
I'm Charlie Stanier. I'm a professor in chemical and biochemical engineering at the University of Iowa. So what drew me to chemical engineering, and what I think draws a lot of us, is how do materials work? What's their chemistry? What gives them their useful properties? And that's material science, but we move beyond material science to the engineering. How can we make that material? How can we make it safely, economically, profitably, high quality, repeatable? And then how can we innovate on those materials so that the next generation is better?
So almost everything you use or touch on a daily basis involves chemical engineering, whether it's pharmaceuticals, whether it's energy conversions, whether it's food or agricultural products, whether it's electronic devices. All of those are products that involve chemical engineers and chemical engineering. It goes well beyond that. We have other engineers who work in the safety industry of making processes safer, more sustainable. We have a number of engineers who work in the environmental field of actually preventing pollutants from leaving processing plants or facilities and cleaning them up. One of our recent graduates worked at General Mills, and she was in charge of the fruit products line. I say fruit products in quotation marks because she was in charge of fruit by the foot and fruit gushers, of making all of those for the United States. So certainly making things is part of what we do. We also have a number of graduates who work in the electronics industry, in Intel and Micron, etc., that really are all based on making materials or making things better for society. Chemical engineering is an enabling degree where students will go on to become environmental lawyers or patent lawyers. Others go on to be medical doctors. And then even others a lot of the students go to graduate school, as our students are highly recruited from the top schools in the country. Schools like MIT, like Berkeley, like Caltech, Minnesota, all have students from the University of Iowa in their graduate programs. So I also would say that our field is a field that values diversity, equity, and inclusion in a way that many others cannot. Unfortunately, in the United States and throughout the world, there's definitely a salary inequity imbalance that fields that are predominantly female are paid much less than fields that are predominantly male. Now, chemical engineering is an exception in many ways to this. Over 30% of chemical engineers are female, and chemical engineers are among, if not the highest paid of any field. In terms of salary equity and gender balance, chemical engineering is unparalleled.
Well, hi, I'm David Merhammer. I'm faculty here in the Department of Chemical and Biochemical Engineering, and I've been in this department for about 31 years. When you're talking about chemical engineering programs, there's a lot of things that are common, among them. I mean, I think the things that make us unique are emphasis on chemical process safety, and two, our very active student chapter. We've had a required safety course for over 20 years. And for most of that time, we've had a dedicated lab, which I think we're going to show you an example of an experiment. The experiment we're going to look at is using a modified Hartmann tube for looking at a dust explosion. And specifically, we're going to look at cornstarch. And dust explosions used to be very common in grain processing and can cause major damage to facilities. And as a result of the safety class, our students are very well prepared for industry. And there's actually a number of companies now that are hiring our students primarily because of their safety background, with safety consulting companies in particular. As far as our student chapter, I've been advisor for the student chapter ever since I came here. We have won an Outstanding Student Chapter Award 26 of the last 27 years, and those awards are given to the top 10% of student chapters in the country, and we've won it the last 15 years in a row. We have done very well in Chemi Jeopardy competition, and Chemi Jeopardy is basically like Jeopardy the TV show, except the categories involve primarily engineering and science with an emphasis on chemical engineering. There have been 10 national competitions, and the University of Iowa, a very small department in comparison to most, have finished first twice and second 3 times in those 10 years, which is pretty impressive, I think. And we beat teams like MIT last year, and in the past like Georgia Tech and so forth, all these big name schools, and they can't compete with us.
I'm a big fan of the department's elective focus areas. We call them EFAs for short. We've worked really hard to make a good set of focus areas, and these give students an opportunity to specialize a little bit, or at least explore a few courses that are in a distinct specialty area.
So my name is Syed Mubin. I'm an assistant professor in the Department of Chemical and Biochemical Engineering here at the University of Iowa. What makes us unique as a program is that we are small enough that we maintain a high level of collegiality and collaboration within the department, while maintaining a research breadth that you would only encounter in large programs. For example, faculty in here work in the areas of atmospheric science, to energy, to polymer science, to drug delivery, to artificial intelligence, and so on and so forth. So what this provides to students is this unique opportunity to learn diverse concepts within the chemical engineering, but while maintaining a good faculty to student ratio, so they could get the level of care that you could only enjoy in smaller programs.
I really like the faculty here because of their willingness to help. If I need help trying to find a mentor within the industry that I want to go into, or if I'm looking for a research department or research lab, I can always count on my advisors. And I've had conversations with one of the professors, and I've sitting down in her office, and we've had talks about like what's going on with my life, updates, how's my research going. So I really like that familiarity. You're not just another engineer, they know you by your name. And I really like that. It gives me a sense of belonging here. I'm also the president of the Society of Hispanic Professional Engineers, and that to me is something that I'm very passionate about. I love advocating STEM-related fields to younger people, younger generations, and ultimately I want to be a role model to those people that may look like me, and show them that if I can be an engineer, and if I can be the president of this organization, so can they. And we don't see a lot of women in engineering. That's something that I think that should change. We always need a new perspective. You know, people have different viewpoints, different opinions, and if they contribute to something, I feel like, you know, they can also make an impact.
Others will talk about this, but research in our program totally illustrate these points of how we make a difference in the world. We have research where, including undergraduate researchers, are using sunlight and taking wastewater and converting that to energy and cleaning the water while they're doing it. We have other research where we're developing sensors that farmers can use to decide when and where they need to water crops. We have other research that focuses on improving drug delivery and especially with the emphasis on vaccine development.
So I'm Jonah Marks. I'm a first-year PhD student here at University of Iowa. I did my undergraduate here. I got involved in research through talking with professors and through hearing professors talk about their research. And then as I talked to more and more professors, they began to learn what I was interested in. So in my sophomore year, after I took the core thermodynamics and chemical engineering thermodynamics, I had two professors recommend, you know, if that's really the sort of subject area that I like, I should go on. And even as a senior, I could take some of the grad courses in thermodynamics. And then I was told the same thing again my junior year. So when my senior year came around, I did that. And through things like that and talking to the professors, it really felt like people cared about what I was interested in. And that's what got me involved in taking more advanced courses and eventually into research. And then by a domino effect, that's what got me involved in, or made me want to pursue a PhD in chemical engineering. For this program specifically, the professors here really care and they'll take the time to get to know you. And for me, it's worked out great.
My name is Austin McKee. I am a fourth year PhD graduate student working for Dr. Syed Mubin. Joined the university for undergraduate chemical engineering in 2013 and graduated undergraduate in 2017 and then continued into the graduate program. As an undergraduate, I did undergraduate research with Dr. Mubin, and I started that halfway through my sophomore year. I would say choose chemical engineering, one, for the flexibility. Any job that you want to get, if you have a chemical engineering degree, there's a good chance that you can get into it. Even if you want to go into medical or the medical field, something like that, chemical engineers can do that, especially here since we have the chemical and biochemical. Both of those components together really help expand where you can go.
I'm Madison Merhammer Cologne, and I am a third-year law student at the University of Iowa College of Law, and I graduated from the Chemie department in May of 2018. I plan to practice patent litigation, which translates really well with my Chemie degree. That provided me really good background and technical knowledge. So hopefully when I work with these patented technologies, I can understand the terminology. And I will say that chemical engineering and law school are very different, but my skills that I developed during my chemical engineering degree have translated really well. Particularly, I think my technical writing skills really helped out during law school, because in chemical engineering specifically, you write a lot and you write a lot of lab reports. And so I became a really good technical writer, which translates really well to legal writing.
A chemical engineering degree is going to give you options. There's a number of different industries that you're going to be able to work in. My name is Jim DeVoe. I'm the Director for Global Energy Management and Environmental Sustainability for AbbVie, which is a pharmaceutical company located in the northern suburbs of Chicago. I'm part of the Industry Advisory Board for the Chemical Engineering School, and I love coming back. We come back twice a year and have meetings on campus, and it's always fun to come back and connect. I've been involved with the mentoring program too. We take students who have just graduated from college, and usually in their first 2 to 3 years of working for the company, we rotate them around in different positions.
In summary, chemical engineers use chemistry, biology, and math to solve problems. We produce products that define our quality of life and make life more sustainable for everyone on the planet.
You guys ready?